In this video, we will take a look at a last algorithm for scheduling called the critical path algorithm. So the first thing we want to talk about is that this thing called a path, and then what is a critical path. So a path is similar to what we experience in graph theory. It's a way to get from here to there. It's a sequence of tasks in the digraph. So if you started here and went here, and then went over here, and then finally went over to here, that would be a path from one vertex to the next. The longest path from the start to the finish is called the critical path. And the reason it's critical is if you want to schedule a job and you look at the longest way to get from the start to the finish, that helps you think about how to prioritize or what we need to take care of first. So similar to what you saw in the module, I'm going to use the critical path algorithm. I'm kind of combining the two things listed there into one. So I'm calling it critical path algorithm using the backflow algorithm. You can see I've missed an M there, backflow algorithm. So here's the steps. One, use the backflow algorithm to find the end time. That's the key, find the end time for each vertex. How do we do that? And here's the little sub steps, A, B, C, D. A is introduce an end vertex and assign it a time of 0, right? So we've talked about that if you have the finish line, you can say that that's 0 hours from the finish, putting it in brackets. And then you move backwards to each vertex that has an arrow to the end and assign it a critical time. That's part B. So if you move backwards in time and there was a vertex here, and we knew that this one took 6 hours, we would say that this is 6 hours from the finish line. And then part C, right? Move from each of those vertices, move backwards and assign those critical times. And in part D, notice that the critical time for the earlier vertex will be that times task time plus the critical time for the later vertex. So in other words, let's say, well, I didn't ever give this one. Let's say this was task 8 and it took 6 hours, right? Took 6 hours. That's parentheses right there. Let's say the previous task that leads to that, one of the previous tasks, let's call it task 5. Let's say it was a 3-hour task. Now that means that we are a total of 6 plus 3 or 9 hours from the finish line. So the number we're putting in the brackets is always adding up the total amount of time from that particular task to the finish line. So then, okay, we're done with step 1. We have those end times down. Step 2 is once you've completed, and I should say once you've completed the backflow algorithm, create the critical path priority list. And we've done priority lists by using the critical times you just found, all right? And the way we're going to do that is, longest to shortest. So we're going to prioritize the things that take the longest. And then part 3 is something we've already worked on, which is schedule using a priority list. Okay, so let's take a look at an example. Here's a rather small digraph. We have a start and a finish already. And so beginning this process, in part 1, we write in brackets how far we are from the finish line. Well, here at the end, we're 0 hours from the finish line. Going back, there's 2 vertices that lead directly to the end, F and G. F, you're 1 hour from the finish line, and that's because F takes 1 hour. And G, you're 2 hours from the finish line. Moving backwards to D, D is a 12-hour task, but remember we have to add in the 1 hour from F, so that's a total of 13. Okay, E, if we move back, E is 6 hours, plus the 2 is 8 hours from the finish line. Moving back to C, C is a 9-hour task, but remember it's 8 hours from E. So 8 plus 9 is 17 hours from the finish line. And you can see that 17 is really at this point 9 plus 6 plus 2. All right, moving backwards from D at the top up to A. A would be 8 hours plus the 13 that we already had gives us 21. And then B, if I can squeeze it in here, B is 5 hours plus the 13. We don't add the A, right? Because B leads directly to D. So it's 13 plus 5 is 18 hours. And then you can see here at the starting line, and we don't have to really list this, but the starting line, what you're thinking is, okay, which one of these tasks, which one of these paths, is the longest? And the longest one really is through A, right? That's the 21 hours. That's my largest number. So my critical path really is here. But what will happen is as I start attacking that path, I don't want to ignore the other paths because as I get past A, notice that D, it doesn't have the longest time. So I'm always creating the priority list according to these numbers in the brackets. In fact, we're ready to do that now. So we're going to create our priority list based on the time from the finish line. It's just basically, as I mentioned earlier, longest to shortest. What's the longest task from the finish line? Well, that would be A at having bracket 21. So A is my first item. Next largest number is 18, right? 18 hours from the finish line is B. The next largest number is 17. That's C. All right, so we did those three. The next largest is 13. That's D. And then 8. That's E. And then G is 2 hours from the finish line. And then the closest to the finish line is F. So my priority list, unlike last week where we just ranked the tasks from longest task to shortest task, now we're ranking it longest to shortest from the finish line. All right. And it's dealing with this idea of a critical path. Okay, so now that we have the priority list, we can schedule using this priority list. And here we have the schedule below. Just for the sake of this one, as you can see, I'm going to use two processors, processor 1 and 2. So I would look at my digraph, and I have quite a few things going on in the digraph already. So I'll just use black ink here. And so we're going to first start by saying, okay, what's ready right away? Well, from the start, right? If we're here at the start, all right, we have 3 paths to choose, right? We can either go to A, B, or C. So all 3 of those are ready. I'm going to put those circled. All right, all 3 of those are ready. And since A is highly prioritized, we're going to assign that first. A is an 8-hour task. There we go. I'm going to assign 8-hour task to processor number 1. There we go. So that will get an A. All right, and then processor 2 will get B, and B is a 5-hour task. All right, 1, 2, 3, 4, 5. That will be task B. All right, since I only have 2 processors, that's all I can assign. I'm moving ahead in my timeline to hour 5. We'll notice that task B finishes. I'll put an X through it. Okay, that does not open anything new because task A and B have to both be done before D is open. So the only thing open right now is task C. C is a 9-hour task, so I will assign C 9 hours to processor 2. 5 plus 9 giving me 14. So there is an outline for task C. Moving ahead in the timeline at hour 8, task A is finished. I'm going to put an X through that. Once task A is finished, now both A and B are finished. So in my digraph, notice that I will now be able to lead to task D. So task D is ready. Task D is the only task that is ready at this point. So we're going to assign that to processor 1. It is a 12-hour task. So 8 plus 12, leading me all the way out to hour number 20. It's a very long task. All right, so that is task D. Once again, moving ahead on our timeline up to hour 14, task C is finished. I'll put an X through that. Once task C is finished, it opens up the pathway for task E. So E is now open, and I will assign that immediately to processor 2. It's a 6-hour task. 14 plus 6 takes me all the way to 20, and they both finish at the same time, which could be good or bad. We're going to find here in a second. Okay, so let's move ahead on the timeline. Right to that hour 20, I'm going to X out both D and E. All right, now when I do that, and once D is finished, I now have F is opened up. And once E is finished, G is opened up. Perfect. I have 2 things to give out. So the first priority is task G, and I'm going to assign that. It's a 2-hour task. Task G goes to processor number 1. All right. And then I will assign task F to processor number 2. That is a 1-hour task. And you can see this works out really well because this one last hour here, all I have for idle time. That's not bad at all once you've seen a few schedules. So I've assigned all of the tasks. We can see that our completion time is very minimal. It looks very good. We have it done in 22 hours, right? The 22-hour mark. We have all the tasks finished. And our idle time is only a total of 1 hour. That's pretty good. So it gave us a pretty tight schedule. Now, this probably is the very best schedule we can do. In fact, it is the optimal schedule. And this critical path algorithm often gives the best schedule. Unfortunately, it does not guarantee it. Let's take a look at a second example, and you're going to have an opportunity to help out a little bit here. So here is a different job. And what I'd like you to do is, again, beginning at that finish line, this is 0 hours, of course, from the finish line. Work backwards to each of the vertices to figure out what should be the bracketed number. In other words, how far from the finish line are we? And it is a cumulative number. Okay, now that you've had a chance to work on some of that, we're going to work a little bit on the scheduling as well. And so let's take a look at some examples or questions from scheduling. Okay, now that you've done that, I hope that you have a pretty good idea of how this critical path algorithm works. And that will be it for this video. Thank you for your time.